In this example, we are going to find inverse Laplace transform by partial fractions. This is example 14. We are going to find the inverse Laplace transform of 2 over s minus 1 over s plus 1 square. Before we find the inverse Laplace transform, we must find the partial fraction of 2 over s minus 1 s plus 1 square. This is equal to a over s minus 1 plus b over s plus 1 plus c over s plus 1 square. This is because s plus 1 is repeated 2 times. So there are 2 terms. One is b over s plus 1, another one is c over s plus 1 square. And we are going to find out what is a, b, c. It is easy to find a. You can use cover up to find a. A is above s minus 1. So you copy the original expression 2 over s plus 1 over s plus 1 square, and then you cover up s minus 1 since a is above s minus 1, and you set s minus 1 equal to 0 or s equal to 1. This means a is equal to 2 over 1 plus 1 square, which is 2 over 4 or half. Next, we can also use cover-up method to find the value of c. c is above of x plus 1 square. So we copy the left hand side 2 over s minus 1 s plus 1 square, and then we cover up s plus 1 square, and we set s plus 1 square equal to 0, which means s equal to minus 1. Therefore, the value of c is equal to 2 over minus 1, which is negative 1. So, we know that the value of a is equal to half. The value of c is equal to negative 1. We still need to find what is b. To find b, you can multiply both sides by s minus 1 s plus 1 square. Then the left hand side is 2, right hand side is a times s plus 1 square plus b times s minus 1 s plus 1 plus c times s minus 1. Let's say I compare the coefficient of s squared. The left hand side is 2, there is no s squared, so 0 s squared on the left hand side. The right hand side, there will be a times s plus 1 square. When you expand out, you get like a times s squared. And b times s minus 1, s plus 1, you're going to get b times s squared. And this is the s squared you can get on the right hand side. That means that b equal to minus a, which is negative half. Alternatively, you can also substitute s equal to 0. For example, substitute s equal to 0, Then you get 2 equal to A minus B minus C. And you know that A is equal to half, B equal to minus 1. From here, you get B equal to minus half again. So we know that B is equal to negative half. And the inverse Laplace transform of 2 over s minus 1 s plus 1 square is equal to the inverse Laplace transform of half over s minus 1 minus half over s plus 1 minus 1 over s plus 1 square, which you can split them up into 3 terms, which is half inverse Laplace transform of 1 over s minus 1 minus half inverse Laplace transform of 1 over s plus 1 and minus inverse Laplace transform of 1 over s plus 1 square. Using the Laplace transform table, we know that Laplace transform of e power at is 1 over s minus a. Therefore, inverse Laplace transform of 1 over s minus a is e power at. Using this, the first term is half times e power t, since a is equal to 1. The second term is half times e power negative t, since a is equal to minus 1 now. As for the last term, we need to do a shifting. This is the same as inverse Laplace transform of shift the s plus 1 to s, to get s squared, and then you have to multiply by e power negative t. So this is using first shift. Right? By shifting s plus 1 to s. And then inverse Laplace transform of 1 over s squared is t. This is because Laplace transform of t is equal to 1 factorial over s power 1 plus 1, which is 1 over s squared. Therefore, the answer we have is the first term is half of e power t, second term is half minus half of e power minus t, and the third term is t times e power minus t, where inverse Laplace transform of 1 over s squared is equal to t. That finished the example.